All right, so welcome to the video on combinations and permutations. So first off, what is a combination and what is a permutation? So here's the difference at the top right here. I have it typed out for you. So it says a combination is an arrangement of objects where order does not matter. And then a permutation is an arrangement of objects where the order does matter. So an example of each of those is a combination would be like if I had 9 people and I said choose 3 to be on a committee, right? So it doesn't matter who's who, I'm just choosing 3 of the 9 people, and how many different ways can I choose those 3 people. A permutation, on the other hand, is if I have 9 people and I want to choose 3 people, but I want them to have specific roles. So if I want 1 to be president, 1 to be vice president, and 1 to be secretary, okay? So that means that if I chose Bobby, Sally, and Carl to be on the committee, and those are just the 3 people I chose, but it doesn't matter if I chose Bobby, Sally, or Sally, Carl, and Bobby. That's the same picking. That's a combination. That's the same choice. For a permutation, though, if I chose Sally to be president and Bobby to be vice president and Carl to be secretary versus Carl to be president and Sally to be VP and whatever the other guy's name was to be secretary, that's a permutation. Okay, so when the order does matter, that is permutation, and when it doesn't matter, that's combination. So if you are given a number of items to pick from, the number of way that you can select those items is given by this formula. So this is number of items, permutations, choosing R. And then how to get that, you would do n factorial divided by n minus r factorial. If we're doing combinations, this is n choose r. We could also write it as in this formation, which we're used to writing. We've seen that before. N factorial divided by n minus r factorial divided by r factorial. So if you look at this, this is how you find permutations, but then to get combinations, you also have to divide it by r factorial. So combinations is always going to be a smaller number than permutations when comparing 2 things, because the order doesn't matter in combinations. Within permutations, it does. All right, so let's get a straightforward example of that. Consider the letters A, B, C, D. How many different 3-letter combinations can you make? All right, so the first one is how many 3-letter combinations can you make? So this is where the order doesn't matter. So ABC and BAC would be the same thing. So in order to do that, you are going to do 4. There's the 1, 2, 3, 4 letters. And then you're making combinations, right? Because the order does not matter. What the heck happened there? And we are doing 3-letter combinations. So that is going to be 4 factorial divided by, and then for combinations, remember it's 4 minus 3, which is 1 factorial, and then r factorial, which is 3 factorial. So that's going to be 4 times 3 times 2 times 1 divided by 3 times 2 times 1, which is just 4. So there are 4 ways that you can make a 3-letter combination, and we could probably come up with them because there's only 4 ways, right? How many different 3-letter permutations can you make? So another way of saying this also is 3-letter combinations where order does matter. Sorry. That's another way of saying it. A little confusing though, right? We'd rather use the word permutations. So that is 4, where you're taking 3 letters, but the order does matter. So this is ABC and ACB are completely different. So that's going to be 4 factorial divided by 1 factorial, because you're doing 4 minus 3 factorial. So that's the same thing as just 4 factorial, which is 24. All right, so this says Sarah has 5 pairs of jeans and is planning to bring 2 of them on her vacation. How many combinations of jeans is possible? So first off, we have to decide if the order matters, right? So I'm not going to think of types of jeans. I'm just going to say colors, like a blue pair and a green pair, right? So if she chooses to bring out of her 5 pairs the blue pair and the green pair, that's not different from the green pair and the blue pair, right? So the order here does not matter. So we will be using combinations. So this is 5 pair of jeans, and she is choosing 2. Order does not matter. Now you could do 5 factorial over 5 minus 2 is 3 factorial, 2 factorial. You can put it in your calculator that way, right? We could do 5 math, go over to probability. Option number 4 is factorial, divided by 3 factorial, so go back to math, probability. Option number 4, 2 factorial, math, which is just the same thing as 2, so I don't even have to do 2 factorial, but just for the sake. I could do it that way, all right, and say that it's 10. There's 10 different combinations that she can bring. Or another way of typing that is I can type 5 math, go over to probability. Option number 3 is combinations. Notice option number 2 is permutations. So option number 3, and then how many different ways can I choose? 2, enter, 10. Right? That's the faster way, so that's the way I'm going to be doing it from now on. All right, next it says a standard poker hand consists of 5 cards dealt from a deck of 52 cards. How many different poker hands are possible? Okay, so how many different poker hands are possible? So now we have to think if the order matters, right? So let's first off, I think I have, yes I do. Okay, so here's all the cards in a deck of cards. So if I get this one, this one, this one, this one, and this one, which would be great, right? That's not different from getting this, 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 and this. It's the same thing, right? So the order does not matter here. So this is combinations. If you see here, there's 52, and it's how many different ways can I choose 5 of them? So that is, let's go back all the way up to the top here. 52, I'm doing combination because order doesn't matter, and I'm choosing 5. So I'm just going to type that in my calculator. I'm going to do 52, math, go over to probability, option number 3, choose 5, enter. And that's a nice ginormous number there. So we got 2,598,960 hands. So that's how many different hands, 5 card poker hands there are, right? Okay, so how many poker hands contain all the same suit? This is known as a flush, okay? So I want to know if, let's go look back and look at this again. How many poker hands contain 5 of the same suits? So I want to get just these 5, or just these 5, or just these 5. And I can do that for any, right? Or this one, this one, this one, this one, this one, right? Like it's just anything, right? It doesn't have to be a certain order, but I got to think about that, okay? So let's just look at just the hearts right here. Or sorry, those are diamonds. My vision's not great, okay? So if you look at that, there's 13 of them, and I want to choose 5 of them, right? So this is showing you that the order doesn't matter of which 5 I have to, so that's going to be combinations. So I'm going to start off with that. So I have 13, choose 5, right? That's the 13 cards in each suit, okay? And you're going to see that whenever we're saying and, we're going to use multiplication, or is going to be addition. So, and I can't forget that I just looked at diamonds. There are 4 different suits, and I have to choose one of them, right? So I either have to choose this, 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 or this to start with. So, and I have 4 different suits, and I'm choosing one. Okay? Whenever it's and, you're using multiplication. Whenever it's or, you're using addition. I'm going to write that down at some point. 13, choose 5 times 4. I hope this goes in there correctly. We'll find out very quickly. Choose 1. What does that look like? 5148. Yep. 5,148 hands. That's how many poker hands that's how many flushes there are. So when you say like, oh, wow, like a flush, it's pretty easy to get. There's 5,140 different ways to get it, but that's out of 2.5 million different hands, right? So it's actually pretty rare to get one. Okay, so I already said this, but I'm going to say it again. When you see and, you are going to multiply. Or when if you're asked, if you're going to say it in a sentence and you use the word and, you're going to multiply. And when you see the word or you hear the word or, you are going to add your probabilities. Okay? All right, so here's an example. You are taking a vacation. You can visit as many as 5 different cities and 7 different attractions. If you visit 3 different cities and 4 different attractions, how many trips are possible? See the word and, I'm going to multiply, right? So I want to choose 3 different cities out of the 5 different cities. So the order does not matter because it doesn't say in this certain order. So I'm going to use combinations. 5 choose 3 and then for this one I'm choosing 4 different attractions out of the 7 different attractions. So 7 choose 4. And once again, the order does not matter. So 5 combinations, I'm going to go math. And then after this, I'm going to stop typing it in the calculator for the length of the video. All right, you can type them in yourself. I have an answer key already out here. 7 math probability, combinations option number 3, choose 4. Hit enter, and there's 350 different trips you can go on. Okay? And that's, once again, the order doesn't matter. So it doesn't say like in a certain order. All right, if I need my calculator, I'll pull it back up. But for now, I'm just going to have my answers. I already made a key before I made the video so that I can get the answers quickly and not waste the time here. It's more of the setup. I feel like we know how to type it in now. Suppose you want to visit at least 8 locations, cities, or attractions. How many trips are possible? So at least 8 means that I can visit 8 or 9 or 10 or 11. I should be writing the word or right here, right? That's instead of comma. Okay. I want to choose 8 or 9 or 10, and I should probably go see how many total there are. Cities or attractions. So that is 13 total because 5, that's 12 total. I swear I know how to add. 5 plus 7 is 12. So I can do 10 or 11 or 12. So since it's or, right, because I can't see 9 and 10, right, I'm going to be using addition. So also combinations because the order does not matter. So I have 12 attractions and I can choose to just go to 8. Or 12, I can choose to go to 9. 12, choose to go to 10. 12, choose to go to 11. 12, choose to go to 12. Okay? And I'm just going to type that straight in my calculator, and you get 794 different trips that you could take. All right, here's the other one. Suppose you want to visit at most 3. So this is 3 or 2 or 1 or 0, right? You don't have to go on it. You don't have to choose any of them. So order doesn't matter. Once again, 12 choose 3, or is addition. 12 choose 2, plus 12 choose 1, plus 12 choose 0. And you might be saying to yourself, I don't even have to put the last one in there, but by choosing nothing, that's a choice. So this is equivalent to 1. So make sure you put it in there, or you can just tell yourself it's 1 and add 1. All right, put that in your calculator. You get 299 different trips that you could be doing. Okay. All right, let's look at another problem here. So it says, from a group of 20 volunteers, you are choosing at least 18 to be camp counselors. How many ways can this be done? So you're going to do 18 or 19 or 20. So 18 choose, no, not 18 choose. There's 20. Choose 18. Or 20 choose 19. Or 20 choose all 20, which there's just one way to do that. And put that in your calculator and you get 200 different 11 ways that you can do this. Okay. So once again, if you think about like the broad idea of this, that there's 20 people in a group, you're going to either choose 18, 19, or 20 of them to be counselors. If you're choosing 18, that's going to give you a certain amount of different ways. That's the 20 choose 18. But then, or I can choose 19 or I can choose 20. All right. A local building supply company is hiring extra help this summer. They need 4 additional employees to work outside and 3 additional employees to work inside. How many ways can these positions be filled if there are 10 applicants for outside and 5 for inside? So we have 10 applicants for outside, right? 10 for outside, and we are choosing, they need 4, right? So for the order doesn't matter how they're choosing these. And they have 5 different applicants to work outside, and they are choosing, where did it go? And they are choosing 3. Pop that into my calculator, and you got 2,100 different ways that they can choose these applicants. All right, next one. In a local election, there's 5 people running for president, 3 people running for treasurer, and 23 people running for cabinet members. If the election results in 1 president, 1 treasurer, and 5 cabinet members, how many different outcomes could the election have? So we're going to look solely at president. There's 5 people running for president, and they're choosing 1. Order doesn't matter. 5 choose 1. And, so multiplication. 3 people running for treasurer, and they're choosing 1. So 3 choosing 1. And there's 23 people running for cabinet, and they're choosing 5. So 5 choose, gosh, I did it again. 23 choose 5. Put that in your calculator, and for this election, there are 504,735 different outcomes that are possible. Okay, let's look more at cards. Now, oh my gosh, I'm into a race. If you've never looked at a deck of cards, touched a deck of cards, this is what a deck of cards looks like. Once again, there are 4 different suits: diamonds, clubs, hearts, and spades. And then there are 13 different, my brain just lost it, 13 different sets of aces. So there's aces, 2s, 3s, 4s, 5s. I can't, not suits. What's the other word? I don't know. My brain is melting on that. But there's 13 different of those. So there's aces, which is, you can look at it as 1 if you want. 2, 3, 4, 5, 6, 7, 8, 9, 10. And then there's jack, queen, king. All right, so it says, in a game of poker, using a standard deck of cards, which is this right above us, how many ways can you get a 5-card hand consisting of 2 aces and then 3 other cards? All right, so if you want 2 aces, there's 4 aces, right, total. So we're going to say from the 4, you're choosing 2. The order doesn't matter. And so we're using multiplication. There's 3 other cards. So we're not looking at the aces anymore. So if I take away the aces, there's 48 cards left. And you are choosing 3 of those at random. Okay? So we have 48 choose 2 times, 4 choose 2 times 48 choose 3. Okay, so there's 4 to choose from here. There's 4 to choose from here. And then there's 48 left to choose from there. Okay, put that in your calculator and you get 103,776 hands. Okay. So that's how many hands have a pair of aces. All right, 3 face cards, which is just the king. These are your face cards right here. So how many different ways there to get 3 face cards? So if you look, there's 12 of them. So 12 choose 3. And 2 other cards. So not including those 12, 52 minus 12 is 40. So we got 40 left over. And you're choosing 2 more because you need to make 5 cards total. Okay. All right, put that in your calculator and you get 171,600 hands that have 3 face cards. Not 3 of the same face cards, just 3 face cards, period. Not necessarily 3 of the same. All right, next we have 1 jack. Okay, so look at your jacks. There are 4 of them. All right, so you're doing 4 and you're choosing 1. And 1 queen, there's 4 and you're choosing 1. And 1 king, there's 4, you're choosing 1. And then 2 other cards. So not a jack, not a queen, not a king. So get rid of the 12. So once again, you have 40 left, and you're choosing 3 cards left. Sorry, 2. I know how to count, I swear. 2 cards left. Put that in your calculator, and there are 49,920 different hands that have that. Okay. All right, now let's move away from cards and talk about TVs. So it says a shipment of 25 TVs contains 3 defective TVs. So let's think about this. There's 22 good TVs and 3 bad TVs. I'm writing that down so that I don't forget, because the 3 is typed in words. It's not like the number 3, and I tend to move past that and forget that I was given that. And how many ways can a vending company purchase 4 of these units and receive? So they're purchasing 4, okay? And it says all good units. So there's 22 good, and we're purchasing 4. So 22, choose 4, right? And it doesn't matter the order. It's just 4 good TVs. So that is 7,315. 2 good units, and you're purchasing 4 total. So out of the good units, you get 2, and then also means you get 2 bad ones. So there's 3 bad ones, right? And you're going to get through 2 bad ones. So 2 good, 2 bad. Okay, 2 good, 2 bad. And that is, I don't have that answer for some reason, 22. Math. Sorry about that. Choose 2. And, nope, get rid of that, delete, and 3, choose 2. Math, probability, 3, choose 2. 693. At least 2 good TVs. So this is 2 good TVs, or 3 good TVs, or 4 good TVs. So we already did 2 good TVs, right? That's 693. Plus, we didn't do 3 good TVs yet. Plus 4 good TVs is right here, 7,315, right? So we just have to do the 3 good TVs. So 3 good TVs would be out of the 22, we're choosing 3, but that also means out of the 3, we get 1 bad TV. Okay, so 22, choose 3 times 3, choose 1. Put that in your calculator, and you get 13,321. Okay, that is it for combinations and permutations today. You can go ahead and get some practice in.